This is a key to worksheet 11.3 part 1, and in this in number 1, actually this whole worksheet deals with the combination formula. So remember the combination form, we talked about permutations in the previous lesson. The combinations formula is this. So the combination formula, if you have let's say n items taken or at a time, and remember the order does not matter. The order does not matter when you're using combination. When you use permutations, the order in which things occur does matter. So the formula for this is n factorial divided by n minus r factorial times r factorial. So that's the formula for combinations. And so number 1a, this is what it says. You need to be careful. You understand the direction. It says do not do the following without using a calculator. So basically, you have to use this formula. You have to show that you're using this formula. All right. So so in 1a, you're told that you want to determine what the combination of 7 items taken 3 at a time is. So according to this formula, so n is 7, r is 3. Okay. So you're going to get 7 factorial divided by 7 minus 3 factorial times, and then remember r factorial, r is 3, so times 3 factorial. Okay, so that's what goes here. Now, you have to show the work. So you're going to say 7 factorial is 7. Well, let's go ahead and do this. So 7 factorial divided by, now 7 minus 3 factorial is 4 factorial times 3 factorial, right? And so that becomes, now the way I would do this is this. So you'd say 7 times 6 times 5 times 4 factorial. I would stop there. And the reason is because in the denominator there's a 4 factorial and you can reduce those out. Okay? So you get 4 factorial, and then I would write the 3 factorial as 3 times 2. Okay? Because you can reduce in this case. And so what happens is I get 7 times 6 times 5 times 4 factorial divided by 4 factorial times, and then notice that 3 times 2 is 6, right? So 3 factorial is actually 6, and that 6 can reduce with this. So here's what I'm going to do. So these 4 factorials divide out, these 6's divide out, and so all you're left with is 7 times 5 is 35. So that's that one. Okay, 35. And again, if you want to just check your work, now remember you had to show this work because that's what it says. But if you want to check your work, your answer in the calculator, then remember how we do this. So you say 7, and then you go to PRB, probability button right here, and then you want the combination one. So you're going to move your arrow until it's on the line, then press equal, and then, what was it, 3? So then 3, and you get 35. Okay? All right, now, in this one, in letter B, and I'm going to go ahead and I may have enough room. Let's see what happens. So this is going to be 10 factorial, right? 10 factorial divided by 10 minus 10 factorial times 10 factorial, correct? Okay, so that becomes 10 factorial divided by 10 minus 10 factorial, 0 factorial, times 10 factorial. Okay, now listen carefully. So you see, I'm not going to do all this work here like I did here, because it's not necessary, because these 10 factorials divide out, right? And then 0 factorial, remember what's 0 factorial? 0 factorial is 1, and so times 10 factorial. So these 10 factorials divide out, and you're just left with 1 divided by 1, which is 1. All right, and then you can check your calculator. So you get 10 probability, move your arrow, and then 10, and you get 1. Okay? All right. Now, in number 2, A and B, just want to use your calculator, so just use your calculator. So you're going to say 12, probability, move your cursor, and then 7, and then press equal, and you get 792. Over here, so you're going to say 12, probability, move your cursor, and then so the combination of 12 items chosen 4 at a time. Remember, order does not matter in any of these. Times, oops, I didn't mean to do that, but that's okay. So what most of you probably do is this. You probably say 12 probability, and then 4, and then you would say times, and then do this one. So 8 probability combinations, 7, and then press equal, and you get 3,960. You could have also done this. You could have said, well, I'm going to find this one first, and then find this one first, and multiply. You could have done that. So let's see what would have happened. 12 probability. Yeah. Okay. 12 probability, and then 4, and then press equal. So you get 495 times, and then 8 probability, and then 7, and then press equal. And then you say 495 times 8 equals 3,960. Okay? All right, now the next part, 3, 4, and 5, it says this. Use your calculator for the application problems below. You must show your setup. For example, show something like this, and then use your calculator. Okay, so number 3, your friend is having a party and has 15 games to choose from. There's enough time to play 4 games. And how many ways can you choose the 4 games to play? So the order does not matter. All right, order does not matter which you play the games. You just want to find out how many ways are there to choose those 4 possible games. All right, so it's going to be the combination of 15 games chosen 4 at a time, just like that. So that's your setup, and then use your calculator. So 15 probability, move your cursor, and then 4, and then press equal. So there's like 1,665 ways. So if you were to actually list those 15 games and then choose 4 at a time, remember, order does not matter. All right, order does not matter. You would have 1,365 of them. All right, now remember what I mean by order does not matter, okay? So order does not matter. So that means this. That means that suppose that your games were numbered 1, 2, 3, all the way to 15. So game 1. So let's suppose the order in which was chosen was 1, 2, 3, 4, and then another one was 2, 1, 4, 3. That's the same. That's the same choice. So that would count as 1. So remember, order does not matter. So that's why in permutations this would matter. That order would matter. So that would be two separate ways. But remember, order does not matter. So if you pick those games and you pick those games, that's the same sequence. Okay? All right, so that's what that means. So that's what combinations mean. All right, your English teacher asks you to read 3 novels from a list of 10. Now, how many ways can you choose which books to read? Okay, so again, the order in which you put the books, in which you choose the books does not matter. All right, so that's going to be a combination of 10 chosen 3 at a time. So that's going to be 10. All right, 10 probability combination 3 at a time equal, so 120. So if you were to list all 10 books and you would, let's say you choose 3 of them. All right, choose 3 of them. Let's say book 1, book 7, and book 8. And then someone else chose book 7, book 1, and book 8. That's the same. That's the same. That's the same way. All right. So in other words, those would just count as the same one. It wouldn't be 2 separate choices. All right. So that means that the order does not matter. So if someone picks B1 first and someone picks B7 first, and they all get the same thing, that counts as one. Okay. And that would be in here. All right, number 5. In how many different ways can a theatrical group select 2 musicals and 3 dramas from 11 musical and 8 dramas? All right, so let's first of all talk about the musicals. So in terms of musicals, you would say combination of 11 musicals chosen 2 at a time times, and then the 8 dramas, you want to pick 3 of those. So the combination of 8 dramas chosen 3. So that's going to be this idea here. All right, that part here. And so then using your calculator, you're going to say 11 probability, and then 2 times, and then 8 probability, 3 equal, so 3080. All right, now if you do each one, so 11 probability combination 2, that's going to be 55. So if you were to pick the 11 musicals and just pick 2 at a time, there will be 55 ways in which that can happen. And then over here, if you take 8, combination of 8 items taken 3 at a time, then that's 56. And so 55 times 56 will give you this. Okay? All right, so that's the key to worksheet 13.1, 15.3 rather, I'm sorry, 11.3 part 1. And so that's the formula you're going to use. And remember, when using that formula, the order does not matter.